Hello and good afternoon, CSI 257 Section 847 students for the first 8-week term for the spring 2015 semester at Anne Arundel Community College. So this semester I'm going to go ahead and redo each of the PacketTracer videos. We're going to do a fresh recording for each of the PacketTracer videos that are going to be due this semester, starting out with PacketTracer Activity 1.3.1.3, which is basically a skills integration challenge that's going to test you on material that has already been covered as part of the CSI 157 and the CSI 158 courses. So the Introduction to Networks and then the Routing and Switching Essentials course. And so let's go ahead and start in with this activity. We've got quite a few tasks here, but this should all look relatively familiar. The scenario, we're basically going to go ahead and configure the HQ router as well as the HQ switch. And as you can see, we have two remote sites. We're going to be running OSPF between those sites, and we have a connection out to the internet, which you're going to see right over here. So let's dig in with what the switch configuration is asking us to accomplish. It says configure remote management access, including IP addressing and SSH. So domain name is cisco.com. So let's go ahead and pull the switch up here and let's enlarge this window a little so we can see a little better what we're doing on the CLI here. So we're going to go from user exec mode into privilege exec, and then from privilege exec we're going to work into global config. The first thing it's asking us to configure is the domain name, and this is a requirement to configure prior to doing the crypto keys. So if I were to say crypto key generate RSA and hit enter, you can see that we're going to receive an error message telling us that we need to define the domain name first. So let's go ahead and do that. So IP domain name, and then simply the name of the domain. And here we're going to go ahead and say cisco.com. It's also asking us to create a password, and it's interesting, you find little typos now and then, and also things that are sometimes not clearly spelled out. Let me pull up, where is desk scribble? There we go. So and typically the lab activities or the PacketTracer activities are a time where you'll have that happen. So this is going to be, and I definitely need to change the thickness on that. So we're going to run into a couple of typos. And so this is going to be one typo that we're going to see right here in the middle of the screen. So the native VLAN, and it's talking about the port assignment for gig 11. When we take a look at a show IP interface brief on the switch, what we're going to see is it's actually gig 01, right? So we'll take a look at that. And this is another one of these little kind of Cisco quirks where it's asking us to configure a user with password it's a secret. Now, it doesn't tell us to make it either a type 5 or a type 7 password, but in the password itself it says it's a secret. So leading you to believe that you would configure this, and the most secure way to configure this is as a secret password. So let me go ahead and clear the screen here, and we'll drop back over here. So watch what happens if I were to configure this with the username CADMIN for CA admin, and we're going to use a secret, which is best practice is that you should use the secret keyword here. If I back up a little bit, you can see our choices are secret, to specify the secret for the user. We could specify the privilege, or I could simply put password. Now the password command results in us having a type 7 password, which you can literally cut and paste into about a dozen sites on the internet, and it's going to give you the password back. So you always want to use secret. It's a more secure method. However, watch what happens here. So I'm going to say secret, and then let's enter in ITSASECRET, and you'll notice before I hit enter, we have 2 out of 70 points. So when I hit enter here, you'll notice that the score does not increment at all. So we're not receiving the credit for running this command. So let's remove username cadmin. Let's remove that. And now let's run it again using the less or unsecure password command. So username cadmin, and I'm just going to simply say password, it's a secret. And you'll notice that our score has gone from 2 to 3. So a little disappointing from the perspective that during the course we've spent an inordinate amount of time talking about how to secure the router and the switch when configuring usernames and passwords and using the secret for the user instead of the type 7 password, which is which simply using the password option. So if I say do show run, and actually we have an enabled, we'll enable password or service password encryption here in a second. So let me go ahead and do that right now. So service password encryption, because I want to make sure we talk about this. So as you can see, we have a type 7 password, which is simply sort of a random string of characters. However, again, I could literally take this password and let me copy that. Let's see if this will work here. Here's my PacketTracer stuff. So let's say type 7 password crack. So Cisco type 7 password decrypt decoder. As you saw, there were a number of sites. We'll come here. I'm going to go ahead and paste in the encrypted password. There it is. I'll hit submit. And there you go. It's a secret. So it is literally that easy to crack these type 7 passwords. So again, if you were struggling with this and you were putting in what they've been telling you to put in as a best practice, which is the secret password, you wouldn't have gotten the points for it. So again, a little disappointing because again, we've spent a lot of time talking about how best to configure the router from a best practices perspective, and that's clearly using secret for the password and not a type 7 password. All right, let's move on. So the crypto key length, right? So we saw crypto key generate RSA, and this is going to generate our key that we're going to be using with SSH. So now when I hit enter, you'll notice it doesn't say you need to define the domain name first, because we've done that with Cisco.com. Now we simply need to go ahead and create the key with 1024 bits. So we do that. Now we've got some SSH configuration. So we're going to say IP SSH version 2. We're going to say IP SSH. We want to limit the authentication retries to 2. And then we're going to say IP SSH. And when those retries fail, right? So after 2 retries, this is how long you're going to have to wait. And the value is in seconds, and so we're going to say 60. So IP SSH timeout 60. And we'll be able to test this at the end. So if I were to say do show run, you can see right there we've got IP SSH version 2. We've got IP SSH authentication retries 2 and IP SSH timeout 60 right along with our domain name. Okay, so clear text passwords should be encrypted. So that was where we ran the service password encryption. And so what this will do is any plain text passwords, for example, when we use the password command, or had we set a password on any of the VTY lines or the console line, those passwords would now be encrypted. But again, with a Type 7 encryption. So definitely not the strongest of encryptions, as we saw. Okay, so let's move on to the next task. So it says configure, name, and assign VLANs. So I'm going to go ahead and say VLAN, and we're basing that off of this chart right up here, right? As you can see right up here, these are our VLAN numbers and names. So when I say VLAN 15, I'm simply going to name it servers. And then VLAN 30 will be PCs. Whoops, sorry about that. VLAN 30 will be named PCs. And then VLAN 45 is going to be native. And then finally, VLAN 60 is going to be management. And I apologize there, I got the name mixed in. And name management. All right, so if I were to do a do show IP or a do show VLAN brief, you can see that our VLANs have been created. The case sensitivity matches what's been provided above in the table. And so VLAN 15 is servers, VLAN 30 is PCs, 45 is for native, and 60 is our management VLAN. So the next task, it says ports should be manually configured as access ports. So let's do a do show IP interface brief. And as we can see, port 1 is up, port 11 is up, all of the other ports are shut down, including, and here's where you're going to see that we've got a minor contradiction. So as you can see, I've got gig 01 and 02 on the switch, but it's saying that the native VLAN is going to be set on gig 11. So unfortunately, that switch doesn't, or that port on this switch doesn't exist. So it's going to be a little difficult for us to do that. So we can tell and we know that it's going to be gig 01. So let's go ahead and make that configuration. So we'll come back down here, name VLANs. Port should be manually configured as access ports. So here's what I'm going to say. Let's go ahead and do the access port configuration right now. So I'm going to say interface FA01. So switch port mode access, and then switch port access VLAN, and that's going to be VLAN 30 for our PCs. And I'm going to say interface, and the server's VLAN is 15, and that is port 11. So interface FA011, switch port mode access, and then switch port access VLAN 15 for our servers. All right, so if I do a do show run on interface FA01, and that's right, the PacketTracer does not like this command. This is a valid command. So if I were to pull up, this is a real Cisco switch here. It's a 3550, and actually let me jump over to 3750, probably a little quicker. So if I were to do a, and even if I was in global config mode, if I do show run interface, and now I'm realizing I'm not sure what the interfaces are here. So how about do show IP interface brief, and yeah, so 60. I'll pick any of these. So do show run interface, and we're going to say FA60, and what might we have something on? How about 2? So this is a valid command, and what this command does is it actually shows you the configuration on the specific port, right? Because if you don't want to have to do show run and then, you know, space bar all the way down here to try to see, okay, what is the last port, you know, port 48, what does it have on port 48? You could just simply do a do show run interface FA6048 on this switch. On our switch, we were trying to take a look at FA01. So I'll go ahead and drop that guy down. And so since we're not allowed to see that, we're going to be stuck with the do show run. And so FA01, as you can see here, it's an access port. and it's in VLAN 30. And then we've got port 11 is an access port in in VLAN 15 for the servers. And if I slide this slightly to the right, we can see that the staff PC should be VLAN 30 and the server should be VLAN 15. Okay, so we've got the VLANs and the port assignments taken care of. So now it says configure trunking. Well, just from looking at our configuration here, and let me slide that back over, just from taking a brief look at the configuration here, you can tell that we've got VLAN 15, which falls inside this 192.168.45.66. That's the IP, but it's inside that network. And then we've got the VLAN 30 network. However, to get out of here, we only have a single connection off the switch into the router. So we should be able to identify at this point that inter-VLAN routing is probably going to be required. And we know from class that there are 3 basic ways that we could handle this. If we've got 2 networks, and I'll come over here to, let me clear the screen here. So we know that if we have a router here, and I've got a switch below the router, and we talked about this on Saturday. If I have a single connection, and this is all one VLAN, and let's just say this is VLAN, we'll use 15, right? I'm okay, because that default gateway, right, this port right here, and let's say this is gig 01, this would be my default gateway. All of my servers plug in down here. I put them into VLAN 15, just like we did above, and this becomes my default gateway address. So we could use, and I'll use 192.168.45.65, we'll say, right? So that would be the address of this router interface, and all of these servers down here, when you go to configure them, you put in, if you were using DHCP, it would pick it up, but if you're putting in the IP, you would put in the net mask, and then you would configure the default gateway. So when we've got one VLAN, right, if this is a single VLAN here, then this is how we could approach this. If I had more than one, and we'll go ahead and say more than one VLAN. So here's my router, make it a little bigger this time, and here's my switch, and I've got my single connection, and let's say that we're going to change colors here real quick. There we go. So now this is a host here, and we'll say he's on VLAN 10. And so we've got a couple guys on VLAN 10. And then I'm going to switch colors up again. We'll go with green, and we'll say, whoops, we'll go ahead and say these guys are in VLAN 20. So now we have more than one VLAN, which means we're going to have to think about how do we want to handle the traffic, right? So here's our switch, and I want it black. There we go. So we've got to think about this, because if we want inter-VLAN routing, we're going to have to configure either a second connection into this router, right? So if this is gig 00, if gig 01 is free, we could use that. And so let's say for VLAN 20, it's 192.168.20, whoops, .0, and we'll say it's a /24. And for VLAN 10, this guy is just 192.168.10.0. So I've got these guys on one VLAN, and I've got these guys over here on a totally separate VLAN. So we have to add this interface. This is one way to handle it, is to add the interface in, right? This would be an access port, not a trunk port, right? Because we're only doing a single VLAN. So same thing here. This would be an access port. And these would simply be configured as they normally would on a router with their IPs. And so this guy would be dot 1 for his subnet, and this guy would be dot 1 for his subnet. So 192.168.10.1 right here, so I'll put the 10.1, and this guy would be 192.168.20.1. And so again, you would configure hosts on VLAN 20 to use the default gateway that we just set up. Now, what's the drawback with this scenario? So what if your boss comes to you and says, yeah, that's great. Well, now I want to add a host in here on VLAN 30. So now we need another interface on our router. And every time he comes to you and says, I need another VLAN, one way to deal with this is to simply start adding in additional connections. But as you can see, there's a couple of problems here. One, you're going to be chewing up an inordinate amount of ports on the switch side, but even more challenging will be chewing up a lot of the router ports. So the alternative to this, and again, so this would be method number 1, right? We've got a single VLAN, you've got an access port, right? So that's an access port that's in the VLAN, right? Whatever VLAN this is, VLAN 15, that's the access port VLAN, and then you've got the single interface on the router. If you've got multiple VLANs and you want inter VLAN routing, then you're going to have to do something like this, or the alternative, which is what we're looking at, is called router on a stick. And that's what we're going to configure for our inter VLAN routing. And again, looking at our diagram, and let's draw that. So we'll make it even larger this time. So here's our router. We've got a single connection that runs into our switch, and we've already configured a series of VLANs here on the switch, right? So we have the file server, and he is on VLAN 15, and then we have the PC, we'll just say the staff PC, and that's on VLAN 30. So if I'm not going to add another interface in, right, if I'm not going to drag another interface down there, which is not what I want to do, then what I can do for the router on a stick is I can stay with a single connection. This port is now no longer an access port. We're going to make it a trunk. And remember, the reason that we make it a trunk is because trunks can carry multiple VLANs. So the access port only carries a single VLAN. So on our previous options and examples here, and this was number 2, on our previous example, we see here we've got a single VLAN. So we've got the access port. He's only carrying one VLAN, so that's okay. Over here, we're staying with access ports, right? But what are we doing? We're adding in new connections every time we have a new VLAN. So again, it's okay that that's an access port. However, the router on a stick is going to require that this be a trunk port, because now what we're going to say is across this single link right here, we're going to be in, I'm making it worse there. This is a tough tool to draw on. We're going to say that across this single link right here, we're going to carry both VLAN 15 and VLAN 30. So that's why it needs to be a trunk. So then what about here, right? So I can't just jump on to gig 00 and then say, yeah, use a default gateway of 192.168.15.1. Well, because what happens to these guys, right? So let's say that this is 192.168.15.0/24 for VLAN 15, and then 192.168.30.0/24 for these guys. So if I hop on this interface on the router, gig 00, and set that for the default gateway, what are these guys going to do, right? These guys are in trouble because their default gateway will need to be on the same subnet, right, as they are. So instead, what we do, and I'll scratch this out here, we're going to go into creating what we call sub interfaces. So we're going to have a gig 00.15, excuse me, and a gig 00.30. And so, again, this is an arbitrary number here, the number that we're using here. So I could say gig 00.155, or I could use any number right here. However, and this is very important, because if you're setting the network up and you're going to be the one maintaining the network, and even if you're not the one maintaining the network, if someone's coming behind you, you want to try to add some sort of logic, right? A logical assignment and allocation of the sub-interfaces so that you've got sub-interface 15, which goes with VLAN 15, which goes with VLAN 15, that is easy to track, right? So that if you know, for whatever reason, if you're having an issue and you see something's going wrong in VLAN 15, you may want to take a look at that sub-interface. But if for whatever reason I were to say the sub-interface is gig 00.375 and it ties into VLAN 15, this isn't going to make much sense. Chances are you're going to have to go to documentation to figure out, okay, so we're having issues on VLAN 15, what sub-interface is that? So again, it's a good idea, right, to keep things in sort of a logical fashion. And so these sub-interfaces, we're going to configure 802.1q trunking on the sub-interface, or the encapsulation, and what will happen is when the traffic comes into the physical interface, gig 00, he knows that he has sub-interfaces configured. He'll look at the VLAN tag, and based off the tag that the VLAN, for the VLAN, gig 00 will say, oh, this is to the sub-interface gig 00.30 or gig 00.15. And we actually have two additional, which are going to be gig 0045, which is our native VLAN, and then we have our management VLAN. So again, from our conversation on Saturday, remember, there are multiple ways to do this, right? So if you're a very small business, you know, single shop, single subnet, this would be your best bet. Let's say you're a medium size, right? Small to medium. Then maybe router on a stick is going to, or I'm sorry, maybe adding some additional interfaces will be the way to go. Because if you can get away with, you know, maybe 1 or 2 VLANs, maybe that's going to work for you. However, if you start to add, you know, here we have 2, but if you had like, you know, 20 VLANs here, and you were trying to deal with just a single router, then this would be your best bet, right? Trunk port, sub-interfaces, and you're good to go. So let's go ahead and step back over here to our activity and pick up where we left off. And it's asking us to configure the name and assign the VLAN ports, and then it says configure trunking, right? So we know again that our connection to the switch is not gig 0, or not gig 11, it's gig 01. So we're going to go from privilege exec into global config. I'll say interface gigabit Ethernet 01. I'm going to do a no shut command, and we're going to say switch port mode trunk. And so we're going to go ahead and bring that interface up. You'll see it's still red because on the HQ router side, we also have some additional work to do there. All right, so what is our next step? We configured trunking. So implement port security, and it's asking us, so it says on FA01, so let's get into interface FA01. So we know for port security, right away, we've got to turn it on. So switch port, port security. And that command has to be there. And remember, from 158, from CSI 158 for the Routing and Switching Essentials course, let me take this off for a second. So what if I were to say switch port, port security, maximum 2 and hit enter? So you'll notice that it doesn't force me. It's sort of an order of operations type scenario here, where I've just set the maximum number of MAC addresses to 2, yet I haven't actually configured or turned on port security on this port, because this does not turn port security on. I could even go so far as to say switch port security violation restrict, and switch port security MAC address sticky. So if I were to say do show run, and we come down to port 1, you can see where you may take a look at this and say, hey, you know what? Check this out. Port security is on this port. However, port security is not on this port. All of those commands that you see right there are meaningless unless you initially say switch port security by itself. So let's add that to the interface. So switch port security. Now port security is on. So if I do a do show run again, and we come down, now port security is on. If this command is not on the port, all of these commands down here are inactive. They are not in effect, right? So be on the lookout for that. Okay, so actually, and I think we have everything we need. So allow 2 MAC addresses that are automatically added to the config file when detected. That is our switch port security MAC address sticky. And the port should not be disabled. So that's switch port security violation restrict, but a syslog message should be captured if a violation occurs. So let's revisit that command. So switch port security violation, and we have 3 choices here. We have protect, and again, they don't give you, it's not very descriptive here. So security violation protect mode. You could almost say, well, yes, I know it's protect mode because it says right there protect. The same thing for restrict and shutdown. So what are the differences here? So let's first talk about shutdown. Shutdown is literally going to put the port in an air disabled state, and it's going to require, at least if we don't do any other config and we simply turn on switch port security violation shutdown, it's going to require manual intervention to go into the port and to no shut the port to bring the port back up. So now we're left with protect and restrict, neither of which shut the port down. So the traffic will drop. However, what will end up happening is the port is not shut down, but the difference is that protect simply drops the traffic, whereas restrict will drop the traffic, but it will also send a syslog message if a violation occurs. So protect does not send a syslog message. Restrict does send a syslog message. So that's a little review, and I'll leave switch port security. Let's make sure I didn't change anything there on port 1. So we're good. All right. So that takes care of that. Now it says disable all other unused ports. So we know we're only using port 1 and 11. So this is where you should take advantage of the interface range command. If you don't do the interface range command, you are literally going to have to go into 20 some interfaces to do this. So I'm going to say interface range FA02 and all the way to 10, and I'm simply going to say shutdown. And then I'm going to say interface range, and let's back out of here. It's not going to work like that. So we'll say interface range FA012 all the way to 24, and I'm going to say shut. And finally, and this is the one, the previous exercises, part of 158, that everybody overlooks. Remember, do show IP interface brief. We have 2 gigabit Ethernet ports. So I need to make sure I get into gig 02 and say shutdown to administratively shut him down, right? All right, so that takes care of the switch ports. So let me exit out here, and I think we are done on the switch side for right now. So my guess is that in taking a look at this, actually, I don't think we're done. So there is a management VLAN, which is going to be VLAN 60. And it has a default, or it has an IP address on the VLAN, which is going to be, I should say, on the sub interface on the router, which we're going to use as the default for management. And so I'm going to talk about the IP default gateway command, and this is one of the commands that's extremely confusing for learners, new learners, because it doesn't actually have anything to do with the routing of the data plane traffic. And remember, the data plane traffic, that's the traffic that passes through the switch. So data plane traffic is going to be traffic that's generated by the PC and by the file server. And so when their traffic comes through the switch, it goes into the router, that's where the routing decision's being made. Remember that these hosts down here, the file server and the staff PC, they already have default gateway entries. They're configured locally on the PC. So they know where to go when they, actually you can say they know where to go when they don't know where to go. So when they don't know how to get to the network that you're trying to get to, like maybe Amazon.com, obviously you don't have a route for that hard-coded onto your PCs. The PC and the server, they have default gateway entries that say, hey, come up here to the router, and the router is going to figure out where to go. That's data plane traffic. Control plane traffic is traffic generated, and we'll say control plane, is traffic that's generated by the switch. So when I'm on the switch and I run a ping command, or when I try to SSH to another server, or I try to telnet to another switch, for traffic that's being generated in the control plane, that's what the IP default gateway command is for. It tells the switch, for your control plane traffic, here's your default gateway. And in our case here, our default gateway is going to be the management VLAN, specifically this IP address on that sub interface. And so really, if you can think about it like this, the PC has a default gateway, and you configure that. We'll click on the staff and you'll see where that gets configured. And what I'm going to say is that is synonymous, or that's equal to the switch having the IP, and it's default, and I believe it's dash gateway. And I'll leave it, I guess we'll write over that as well. And this is all on one line, by the way, so I apologize. I didn't want to write into here, but ended up doing it anyway. So, but the key here is to remember, the PCs and your servers, they have default gateway information, right? They don't get it from the switch. The switch isn't telling the hosts, hey, this is your default gateway with the IP default gateway command. But the switch, for its traffic that it is generating with ping and SSH and telnet and traceroute, whatever else it's doing, it needs to know, hey, for my traffic, just like the PC does, where do I send it if I don't know where that network resides? That's your That's your IP default gateway command. All right, so let's clear the screen here, and let's go back. And I'm actually going to put that in there because I'm 99.9% sure that we're going to need this on the switch. So IP default gateway, and again, for my management VLAN traffic, will be 192.168.45.33. And we're going to do the sub interfaces here in a second, but that right there is going to be the default gateway for control plane traffic that the switch is generating. Because again, VLAN 60 is our management VLAN. So I'm going to go ahead and hit enter. and we actually were just credited a point there, so that definitely was probably something that was going to be required. Okay, so we're at 25 out of 70. We've got 50 points to go. We've still got some router configuration tasks here, specifically one of my favorite topics, which is NAT. So let's go ahead and jump in. So on the HQ router, let's pull up the router, and we are going to configure inner VLAN routing. And that's what we were talking about again over here. Quick review, right? We've got a single VLAN. We're good with a single connection. If we start to pull in multiple VLANs, if we don't do a router on a stick, we're going to need an interface on the router and on the switch, right? Access ports on the switch and just normal routed ports on the router for every single VLAN, right? And that may work. You may be, if you have 2 VLANs, that could be something that works for you. However, let's say you've got 20 VLANs. Chances are, if you've got a smaller router, a 2901 or an 1841, even a 3745, you may not have 20 interfaces on that router. And then again, you're going to be chewing up 20 ports on your switch. So we're going to do a router on a stick, right? Okay, so let's go ahead and get that configured. We've talked about it enough. Our trunk port is already configured on the switch side. So configure inner VLAN routing. And I'm going to have to scroll up just a skosh to get all those addresses. So we're going to go, let me back up here. So from privilege exec, we go into global config, from user exec to privilege exec into global config, and we're going to jump into interface gigabit 00. Now remember, .15 for VLAN 15. So the first thing we need to do is set the encapsulation type to .1Q, and then followed by what's the VLAN, right? What VLAN tag is subinterface 0.15 going to be looking for? Well, we know he's going to be looking for VLAN tag 15. Then we're going to put the IP address on there, which has been provided for us, 192.168.45.65. And the subnet mask has also been provided, 255.255.255.192. So this would be a slash, not a 25. This is going to be a slash 26 because we're borrowing 2 bits from the network portion, or from the host portion for the network. All right, so we'll set the IP address on that port as well. So we've got the in-cap done. So now if I do a do show run, yeah, I have to do a do show run. Can't do just the interface. You can see the main port, so the parent port is in a shutdown state, which is why we didn't see a message bringing up the sub interface. So we're going to activate them all at the same time. So as you can see right here, we've got gig 00.15. We've got the IP address on there. So now let's go ahead and go into gig 00.30. And I'm going to show you what's going to happen. There's order of operations here. The in-cap, remember, the encapsulation, I told you it had to be done first. So if I try to go IP address and do 192.168.45.20 or 129, let's watch what happens here. Oops, sorry, we'll get the 255, 192. So you're going to receive an error message. It says configuring IP routing on a sub interface is only allowed if that sub interface is already configured as part of an IEEE 802.10 or 802.1Q or ISL VLAN. So remember, ISL, that's Cisco proprietary trunking protocol, which is 100%, not only is it deprecated, you should not be using it, and on newer code, it doesn't even exist. There's not even an option to do ISL trunking anymore, encapsulation. So we've got to put the encapsulation on there first. So it's an order of operations thing where we want to make sure we do incap.1q. The VLAN tag is going to be 30. Now I can go ahead and pull my IP address back in there, and let me double check to make sure that's right. Okay, so now let's finish out the rest of these. So 00.45, incap.1q 45, for the VLAN tag that we're going to be expecting. IP address is going to be 192.168.45.17, and the subnet mask is 255.255.255.240. And we'll hit enter, and then let's go into interface gig 00.60. Whoops, don't want to leave that off. .60. We'll get our encap, right? Order of operations. We've got to get our encapsulation set first. Then we can add in our IP address, 192.168. And this is going to be .45.33. And those are the default gateway addresses for any hosts, including the switch, right? The data plane the control plane traffic for the switch is going to be using that right there. And let me make sure I get this right. 255, 255, 240. And there we go. So our inner VLAN routing on the router has been configured. But again, take a look here. We've got red lights on both sides. So I've been setting these interfaces up. Now we need to make sure that we go into the parent interface and say no shut, because this will bring up all of our sub interfaces. And as you can see, the lights went from red to green and orange. And so what's going to take place now is on the trunk port, it's going to go ahead and go through its spanning tree machinations. And once it converges and everything is fine, it's going to go from, we were in the disabled state, right? Remember the 5 port states for spanning tree and I believe we are, I'd have to double check, but I think we're just running the IEEE spanning tree, which Cisco refers to as PVST plus, per VLAN spanning tree plus. And the reason that you see, and this is also typically a point of confusion, is with spanning tree, and our port is now up. So when you see, if you do the do show spanning tree and you see protocol IEEE, that's the legacy 802.1d spanning tree protocol. So people will typically just say, spanning tree protocol. When you see the IEEE, that means that you are running per VLAN spanning tree plus. And not to go into a very long history, but to make sure that I clarify this, the plus sign, sometimes you'll see, and you shouldn't see this anymore, but in older documentation, you'll see references to PVST. In fact, when you look on the Cisco switch, that's the command that you actually run. So if I were to pull back up, and not my iTunes library, if I were to pull back up the switch that we were on, and I said, show spanning tree, and I want to do this on a real switch, you can see here where it says spanning tree enabled, protocol is RSTP. So this is rapid spanning tree protocol 802.1W. But we'll get back to that in a second. So when I say spanning tree mode, what are my choices? My choices are PVST, MST, and rapid PVST. And so for CCNA, we're concerned about PVST and rapid PVST. But why? Why doesn't it say PVST plus? So on this port, or on this switch, I should say, if I were to go into interface FA6019 and say switch port trunk encapsulation, this is why. So if you look here, you can see that I can choose ISL, right? I had mentioned ISL earlier. So here's .1Q. And again, this is a 3750. It's an older switch. I think I'm running probably 1255. So what version am I running here? So let's say do show version. So yeah, 12255. So older version of code. And ISL is actually a choice. Now, here is the difference between the PVST plus and the normal PVST. If you're using ISL, it's PVST. If you're using 802.1Q as your trunk encapsulation, it's referred to as PVST plus. And there's a much more complicated explanation as to why this is the way it is. But again, that is legacy. And so the same thing, if you see RSTP, Rapid Spanning Tree Protocol, this is 802.1W. And it's actually rolled into the, I want to say it's the 802.1Q 2005 or 2004. I can't remember exactly. 2005, maybe 2004. But anyway, this has been rolled into a larger standard. And the same thing. You saw that what we see in the switch is it says protocol is RSTP. However, what is Cisco? That's the protocol. The mode on Cisco switches is RPVST plus. So Rapid per VLAN Spanning Tree plus, same thing. When you're using 802.1Q, you'll see reference sometimes, to RPVST with no plus. That was referring to legacy ISL, right? So again, not doing a whole spanning tree session here, but wanted to make sure that we touch on this because this is definitely a massive point of confusion, because students will sometimes find older documentation and say, well, it says PVST, but the book is saying PVST plus, and then I look at the protocol and it says IEEE, and then the mode just says PVST, right? So even when you're using 802.1Q, it doesn't add the plus on here. This is just, it's understood that if you're running 802.1Q, you're doing per VLAN Spanning Tree plus, and any newer documentation you see is going to have the correct reference showing PVST plus. Same thing here. Rapid per VLAN Spanning Tree plus, right? And this is the mode you should be running. If you're not doing MST, which is the multiple spanning tree, right, which is based off of RSTP, Rapid Spanning Tree Protocol. If you're not doing that, you should be doing RSTP, Rapid Spanning Tree, or what Cisco calls Rapid per VLAN Spanning Tree plus. Because again, this is the standard protocol, RSTP and IEEE. Those are the standard protocols. Cisco has taken those and they've added their own secret sauce, and it's Rapid per VLAN Spanning Tree. Because this standard, right, by itself, this will only work with one VLAN, right? The standard, not what Cisco's done. And this is why Cisco did what they did, is so that it would work with per VLAN, so multiple VLANs. Same thing here. RSTP, the standard, is for a single VLAN. Believe it or not, right? It's for one VLAN. So Cisco said, okay, that's great. We like the standard. We're going to take it and we're going to turn it into we're going to add our secret sauce, and now it's Rapid per VLAN Spanning Tree plus, because 802.1Q is kind of the de facto standard today. However, you'll find, if you get into legacy environments, you'll find ISL in a lot of environments in some places. And that would be referred to as just RPVST if it's using ISL. Okay, so we're going to leave that conversation there, and I'm going to come back over here. So our inner VLAN trunking is set up right now. Let's take a look at the next task that we've got. We're almost done here. Configure DHCP services for VLAN 30. And this is something where you might think I'm going to type in IP DHCP pool, and they want us to call it LAN. And we're going to create this pool called LAN. And what are the options we have here? So we obviously know it's for VLAN 30, so we're going to add in that default router address. So what did we say our default router address would be? It's going to be the IP on the sub interface for our VLAN, which is that guy right there. So let's say 192.168.45.129. So we'll add the default router in. We're also going to add in the network statement, which would be 192.168.45.128. And our network mask, which is already provided for us, is 255.255.192. And a 192 is a slash. Think about it. If we borrowed 1 bit, we've got 128. 2 bits, 192. So it's going to be a slash 26. So I'll add in the network statement there and hit enter. Now, I'm not sure, and actually I'm not sure if you get points for this or not, or if they're expecting you to do this. But remember, when I put that statement in there, what I'm saying is, for my DHCP pool, you can take any address out of that pool. Now, we already know there are 2 things in VLAN 30. The PC, and he's going to use DHCP to get his address, but we have this default gateway address. So what do we want to do? Do we want possibly maybe another host or the staff PC to come up with DHCP and send out the DHCP discover and the DORA, discover, offer, request, accept? Do we want it to take or to have that router, maybe give out by mistake this 129 address? We don't. So we're going to say IP DHCP excluded address 192.168.45.129, because again, we don't want the router to give that address out by mistake. So we're going to exclude it, and we've got 43 points. I'm not sure if you're awarded anything for this or not. You're not, but that's okay, because you definitely want to exclude that default gateway address. We don't want, because if we were to plug in the staff PC and he gets that address, guess where all the traffic from that VLAN is now going to be going? It's going to be going to the PC when it's trying to get off of that subnet, and that's not what we want. All right, so we'll exclude the address anyway. And what do we have next here? So we did DHCP with LAN. So implement routing, and let's go ahead. So router OSPF 1, and remember, 1 is the process ID, right? And this is locally significant in our scenario. The process ID can be 1 on this router, it could be 50 on B1, it could be 180 on B2, right? So this is significant, it's locally significant. So we want to set our router ID. I'm going to say 1.1.1.1, and it says configure 1 network statement for the entire 192.168.45.0 network. And then remember, with OSPF, it is the wildcard mask. And then what area do we want this to be in? And we're all going to be in area 0. So now remember, we're on the HQ router, and we are going to be establishing an OSPF adjacency with, and there we go, with our neighbor who's B2 and B1. We're going to be establishing adjacencies, OSPF adjacencies with them. So if I do a do show IP OSPF neighbor, you can see we've got 2 neighbors, one out serial 001 and the other out serial 000. And we can see the IP addresses here, right? 45.9 and 45.2, which correspond to 45.2 is up here. So the router ID for router B1 is 2222 or 2.2.2.2, and the router ID for router B2 is 3.3.3. 3.3.3.3.3.3. All right. So this is serial 010, and that's our link out to the internet. So it's asking, as it says here, it says disable interfaces that should not send OSPF messages. Well, we've got 2 of those. So I'm going to go ahead and say interface serial 010, because that's our interface out to the internet. And we are definitely, I apologize, let me go back into router OSPF 1. So I wanted to do passive interface serial 010. And that's going to make sure that we're not sending OSPF hellos out to the internet. And maybe we're, it shows a little cloud right there, but maybe you have a connection to a service provider like an AT&T, a Verizon, Hurricane Electric, Sprint, any of the service providers that are out there. So we also do not want any hellos going to passive interface gig 00, right? Because gig 00, that's our LAN facing interface. We don't have anybody down here that's running OSPF. So we don't need to send advertisements, hello packets down here, trying to find OSPF speakers. All right, so that should do it for, and then interesting, right? So it says configure a default route to the internet. Now it doesn't tell you whether it wants you to do a default information originate, which you won't get the points if you do that. So it just wants a default route. So we are literally going to configure IP route quad zeros twice. And remember, we have a couple choices here. We could put the outbound interface, since this is a serial link and it appears to be, it is a /30, so I could say serial 010. Now, why do we get this message? And it's interesting. You can see in a number of the forums, people talk about why you get this message. So here's why you're going to get this message. And it has to do with recursion. And this was from the first Introduction to Networks course for CSI157. It says default route without gateway, if not a point-to-point interface, may impact performance. And here's why. If this for whatever reason was a multi-access segment, so let's say this ran to a switch and there were like 5 or 6 other routers in the switch, what's going to happen is it's going to have to do a recursive lookup every single time, because it's not going to know which of these additional routers you want me to go to, right? Because I'm just telling it to go out this multi-access interface, and if there are 5 routers there, which one's my next hop? How do I figure that out? Well, the way I have to figure that out is I have to take a look at the destination IP, and then I've got to do my layer 3 to layer 2 lookup to figure out what router am I actually supposed to be going to. Whereas if I were to put the next hop IP address in here, and actually let me do we'll pull that off. If I were to put the IP address in here, and the next hop is going to be 128.107.50.65. When I put the next hop IP in here, there's no doubt what my next hop is. I know that irrespective of whether it's a point-to-point link or a point-to-multi-point link, right, or a multi-access segment that I'm going to, I have the exact IP address, so I don't have to go into the routing table and do a recursive lookup to try to figure out, okay, I know I'm going to 128.107.50.65, but it just shows me that I'm going out serial 010. So where is that? Where out of serial 010 is that interface? I'm going to have to ARP every single time I'm trying to go out that interface. So that's why in a multi-access segment, you want to use the IP address, give that next hop IP, and no matching route. I have the no version there. So no matching route because we haven't put it in there yet. So let's drop it in there. And we should see that we got the 2 points for that. So again, on a point-to-point segment, you can go ahead and use that command. You're going to see this warning because what it's telling you, and the reason it's going to impact your performance, and on a large enterprise network, I've actually seen this where it was a multi-access segment and the interface was given. It was like, gig 615 or 614 or something like that. And it went out to a multi-access segment. Every single time traffic is going to be going out that interface, it's going to have to do an ARP to try to figure out what's the layer 2 address that I need to jump to on this multi-access segment. How am I going to get to this IP? Because I don't know, right? Okay, so we've got that configured. And where does that leave us? That's our default route. So now we have NAT. So we're just about ready to wrap up here. So what do we have for our NAT configuration? So it says configure a standard one-statement ACL, number 1, all IP addresses belonging to the same subnet we were just working with there. It says they're allowed. So again, very simple. Access list 1, permit 192.168.45, was that right? 45.0, and we'll use the wildcard mask of 000.255. So there is our one-line ACL, which we're probably going to be using here with PAT. So now it says, refer to your documentation and configure static NAT for the web server. Is it the web server? For the file server, I apologize, for the file server. All right, so how do we set up static NAT for the file server? And static NAT is probably the easiest NAT to deal with. And we need to get, is the file server IP up here? Or wait, did I go right by it? I was looking for the, oh, actually, let me slide over a little bit. Sorry, I was looking for the file server IP, and I realized it's right here. So static NAT is very simple, right? Static NAT, in our case, is not going to refer to the access list. We're simply going to say IP NAT inside, right, because it's being natted inside, source static, and then the inside local IP 192.168.45.66. Again, that's our inside local, and it's going to be mapped to our our inside global, which is 64.100.32.58, right? So IP NAT inside source static, and then our inside local, and what inside global is it going to match to? And that's our 64.100. So we'll hit enter. And again, static NAT, very simple to configure, and one of my favorite to configure as opposed to the other types of NAT. The dynamic NAT, and then the PAT, which is basically dynamic NAT overload. So let's go ahead and take a look. What are we going to be asked to do next here? So it says configure dynamic NAT with PAT. So NAT with PAT is NAT overload or PAT, port address translation, using a pool name of your choice. So we'll say IP NAT pool, and what are we going to use for the name? We'll just go ahead and simply say, I'll just say NAT-pool. All right. So, oops, I apologize. And then, yeah, the start address, I forgot about that. So, pool name of your choice, a /30 mask, and these two public addresses. So, my start IP is going to be 64.100.32.56, and then my stop IP, or the end IP, is going to be 64.100.32.57, and then we specify the net mask. And we know we're going to be a /30, which is 255.255.252. So that's going to be our /30. So what we've just done right there is we haven't actually turned it on any interface, right? All we've done so far is we've basically said this is our NAT pool, right? And that's the name of the pool, which is NAT pool, and we're using those two addresses, and our net mask is a /30. So we're going to go ahead and add that statement in, and then it doesn't actually tell us. I'm trying to see here if it tells us. Okay, it doesn't tell us. So this is kind of where, again, you don't have the instructions. You're probably looking at this thinking, wait a second, I'm 15 points short of completion, yet I've done every step. Well, you may have done every step that they show you here, but there's some other things we need to configure. Remember, we need to go ahead and say, and we're on the HQ router here, I'm going to say interface, let's do show IP interface brief. We need to turn NAT on. So we'll start with serial 000. I'm going to say IP NAT inside, right? Because remember, the access list that we created is going to allow NAT for the whole 192.168.45.0 subnet. That includes the sales 1 and sales 2 VLAN range. So IPNAT inside on that interface, and then serial 001. Same thing, IPNAT inside. We want to do our IPNAT outside on interface on our internet-facing interface, so serial 010. This will be IPNAT outside, because that's where you're going to be going out to the internet. And then finally, we need to now go into our sub-interfaces. So what two VLANs do we have there that may need to go to the internet? I'll go ahead and put it on VLAN 00.15. We're going to say IPNAT inside. Interface gig 00.30. IPNAT inside. And we're going to say interface gigabit 0.60 for the management, IPNAT inside, and I guess we'll put it on, let's see if we, we'll go to interface gig 0.45 and IPNAT inside. All right, so we have all of our inside and outside NAT statements set up. The last thing that we're going to need to do is now we need to associate the access list that we configured, that one-liner. We need to set that guy up so that he works with the pool that we created. So how do we associate those two? So what we're going to say is IPNAT inside, and remember we said source, and here's where we had, for the static route, we just simply said IPNAT inside source, and that was static. And then we gave our IPs, and we were done. However, here, we need to say list, right? The access list, 1, and what pool is this going to be tied to? And we just said NAT pool, and a question mark. Now, very, very important right here, because this is the single difference between configuring dynamic NAT and NAT overload, or PAT, is that one option right there. If I were to hit enter right here, we would be doing dynamic, because you can see, and I can't get that out of the way. You can see right here, I could hit carriage return, right? And the reason I could hit carriage return without any option right there is that would give me dynamic NAT, right? But we're not doing dynamic NAT, because dynamic NAT's not using the ports, it's actually using IPs. So we want to use port address translation, because we're using what are we using? 2 addresses, right? So if I was doing dynamic NAT and I hit enter right now, as soon as the first 2 hosts tried to go to the internet and took those 2 addresses, everybody else would not be able to get to the internet. We want port address translation, which is what's going to happen with overload, right? This is overload and address translation. So that we can have, we've got 2 addresses, and each address theoretically is going to give us 65,000 plus connections, right? So theoretically 65,000 plus hosts would be able to go ahead and per IP, right? So what is that? 130,000 altogether, which obviously for our subnets here, 130,000 is probably good. But that's the difference. Remember that overload, this equals PAT, port address translation. We have to have that overload command in here. If we don't, what we're saying is the first host that tries to get to the internet, if it's like the staff PC here, he's going to get this address. The second host, and maybe it's sales 2, he's going to get that IP address. Sales 3 is going to try to go to the internet. No IP available. He's not going to be able to get to the internet until these addresses become available. One of those addresses becomes available. All right, so let's clear that out. And so again, very critical. This is the difference in configuring, and we want overload. So again, IPNAT inside source. I could say static if I was doing static, but we're doing an ACL that's only going to allow the 192.168.45.0/24 hosts, anybody in that range, to use the NAT pool, which we defined as the 64.132.56 and 64.132.57, right? And so that's the command that we're going to need. And so that sets up our pool. So now we've done our inside and outside. And as you can see here, if you take a look, we're at 60 out of 70. So let's take a quick peek here. We know we're going to have to try to get a DHCP address here. So let's come over to the desktop, and this is what I was talking about. And again, it's similar on Windows. This is not the same. Where you would put in your IP address, you would put in your subnet mask, and then there you go, your default gateway, right? So if I'm on VLAN 30, my default gateway is 192.168.45.129. However, we want to use DHCP. So I'm going to click the DHCP button and look at that. I get my IP address, I've got my subnet mask, and bingo, my default gateway, right? So there it is. So let me go ahead and let's take a quick look here. Can I ping out to 64.100.150.10? Let's see if we have any success here. And it might have to ARP out. So request timed out, and then look at that. All right, we've got connectivity. The sales PC, do we have any information on those guys? We do not. But let's come over to our switch, right? We'll talk about these 8 points we're missing here in a second. Come back to the switch. If I were to go from user exec to privilege exec, and I'm going to run the ping command here to 64.100.150.10. Now remember, this is a ping command. This is control plane traffic because it's traffic being generated by the switch. I'm going to hit enter. It might have to ARP out. And I don't have any connectivity. So let's go ahead and do show run. Oops, I'm sorry. Show run. Let's make sure we have our IP default gateway statement. And what could it be? So let's check back on the router here. And I think I left off the native command gig 00.45. When we configured that, do show run, did I not put native in? I did not. So here's what we want. We want incap.1q 45, and what is our native VLAN on this trunk link? It's going to be 45. So let me make sure I get that properly added in there. So do show run. You can see that 45 is the native VLAN. So let's see, let's make sure we save our config, and let's pull our switch back up, and let's take a look here. Let's run that ping command again. See if we have any better results. 64.100.150.10. We do not. So let me try to ping the gateway from the switch to that headquarters router. So my default gateway, which is the 192.168.45.33, copy and then paste. Can I ping my default gateway? I can't ping my default gateway. So why is that? We've got the default gateway configured. Let's take a look and see, do we have VLAN 60 configured? So show run, or show IP interface brief. So only VLAN 1 is configured. We don't even have VLAN 60 configured, and you can see here we should. That's our management VLAN. So I'm going to go ahead and go into global config and say interface VLAN 60, and you can see the protocol changed to up immediately. Let's add our IP address in here for that. It's going to be 192.168.45.34, and this is a /240, and .240 would be slash what? 128 plus 64 is 192 plus 32 is 224 plus the fourth bit if we were to borrow it. So this would be a /28. So IP address, we'll add that in there into our VLAN, and now let's try to ping. So I'm going to say do ping 64.100.150.10. And let's see if VLAN 60, which is our management VLAN, and there we go. We've got connectivity out. So that's good. Let me see if I can ping. Let's try to ping one of the routers over there. 192.168.45.1. Perfect. How about 45.2? Perfect. All right. So we've got connectivity out, and we're looking good. So we've got 66 out of 70. And so back to the switch config. Do show run, and let's go all the way to the bottom here. You can see that the VTY lines, we never really secured the VTY lines. We set SSH up, and what were the instructions? It says configure remote management access, including IP addressing and SSH. So it had us configure SSH, it had us configure this username. So the assumption would be that we're going to go into, and let's back out to global config, line VTY, VTY 0 through 15. And I'm going to say login local, because we've configured the username. And remember, the difference between login and login local is going to refer to the local database, right? So local password checking, and that's that account that we created. It's going to be checking that to see if you're allowed in. If we don't do that, if we just leave login, all login is going to do is it's going to check to see what's the enable password, right? So we put login local, then we want to put transport input SSH, because we don't want telnet to be used. So we're going to say transport input SSH. So that got us an extra point. So let's check our results right here, because we're missing two things, maybe one thing worth 2 points, and let's see what those may be. The native VLAN on Gigabit Ethernet 01, excellent. On the trunk link, we're missing that, and that's it. That's our 2 points. So let's go ahead and step back over here, and that was a great catch by the grader, because interface gig 01, when we set up, let's take a look at gig 01. When we set it up, we just said switch port mode trunk. We never said switch port trunk native VLAN 45. And that's going to give us our final points, right? So from here, you could test configuration. I think if you can get onto the outside host coming to the inside. But again, that is PacketTracer activity 1.3.1.3, and this is our skills integration challenge for 257, and we've covered quite a bit in the skills integration challenge. We talked a little bit about inter VLAN routing, the 3 options that we were looking at there. We talked a little bit about spanning tree and some of the things that you'll see with spanning tree, and most importantly, we've got this assignment knocked out. All right. So that concludes our activity for this evening. I really appreciate you guys watching, appreciate your time, and hopefully this has helped you out, and maybe you understand a little bit more now about Cisco routing and switching than you did before. Okay, I will see the CSI257 Section 847 students. I will see you guys on Saturday morning at 8 a.m. Have a great week, everyone.